Good morning, students. In this lesson, we are going to look at chemical weathering. The other time we studied about the various types of weathering, and we said that there are three different types of weathering. We have the physical weathering, sometimes we call it mechanical weathering. Then the second type is chemical weathering. Then we have the biological, or sometimes we call it biotic weathering. Now, we are finished about the physical weathering processes and the forms, how it operates. So in today's lesson, we're going to look at the chemical weathering processes. In this particular lesson, we should be able to, at the end of this lesson, define chemical weathering. Then we should be able to explain the various forms of chemical weathering, or the chemical weathering processes. Now, in terms of definition, chemical weathering is the disintegration or breakdown of rocks by chemical means by chemical means while changing the end product of the weathered rock particles. In other words, there is a chemical reaction taking place during the process of chemical weathering, and this will result to the production of new chemical compounds within the weathered rock fragments. Let me give this illustration. For example, if chemical weathering takes place in a limestone, limestone is a type of rock which is made up of calcium carbonate. Now, if calcium carbonate succumbs to chemical weathering, then the end product of this calcium carbonate will produce something different. For example, it produce calcium hydrogen carbonate, which is completely different form of completely different type of limestone. Now, let's look at the various forms of chemical weathering. The first important form of chemical weathering is what we call the dissolution weathering. Dissolution weathering is a type of chemical weathering which is brought about by pure water dissolving certain soluble rock minerals, most importantly water. You know, some minerals, for example salt, can really dissolve in pure water. Now, if there are rocks which are made up of salt crystals, then these salt crystals in the rocks are attacked and dissolved by the pure water, most especially rainwater, then the rock will become weakened up because of the removal of some of these salt crystals in form of solution after dissolution. So the major rock mass will become weakened up and eventually it crumbles down. So this form of weathering, where the parent rock is destroyed by the process of dissolving the minerals in water, is a dissolution weathering. The basic type of rock which succumbs easily to dissolution weathering is the rock salt. There is a particular type of rock salt, if you may remember your topic of rocks. A particular type of rock which is made up of mainly the combination of salt, which is known as a rock salt. So rock salt can easily succumb to the process of dissolution weathering. Then the second type of chemical weathering is what we call the carbonation weathering. Sometimes we call it solution weathering. This form of weathering occurs when highly soluble rocks such as limestones and dolomites are attacked and dissolved readily in carbonic acid, and that's why it is called carbonation weathering. How is this weathering process possible? This weathering process occurs when rainwater passing through the atmosphere dissolves carbon dioxide, which is plentiful in the atmosphere. And when it dissolves the carbon dioxide, it will produce hydrogen carbonate. Now, this hydrogen carbonate is a weak form of acid, carbonic acid. Now, this carbonic acid, when it lands on rocks such as limestones and dolomites, they can easily be dissolved. Remember, limestone is made up of calcium carbonate. Now, when the weak carbonic acid attacks the calcium carbonate, it will dissolve it and converts it into calcium hydrogen carbonate. Calcium hydrogen carbonate is a solution form of calcium carbonate. So in other words, the carbonation process will dissolve chemically the calcium carbonate, the limestones, which is made up of calcium carbonate, into solution form, and it produces calcium hydrogen carbonate. So in this sense, you can see that chemical weathering has already taken place because the calcium carbonates or the limestones are chemically dissolved, and the resultant effect of the weathered particles are what we call the calcium hydrogen carbonate, which occurs in a solution form. So that is the carbonation weathering processes. The third type of chemical weathering is what we call the hydration weathering process. Hydration weathering process. This form of weathering occurs in rocks which can readily absorb large amount of water. And when these rocks absorb water, they can expand in volume because of the absorption of water. And this increase in volume or expansion of the rock due to water intake will produce internal stress or weaknesses within the rock, and eventually the rocks are easily subjected to other forms of weathering processes. For example, the most commonest type of weathering is the weathering of rocks which are made up of iron. For example, when hematite, which is a form of iron compound, is attacked by hydration weathering, then it will be converted into limonite. Limonite is another form of iron compound which is completely different from the hematite. So in this case, you'll find that there is a chemical change which has taken place within the rock from hematite to limonite. However, this form of weathering is reversible in the sense that when the water evaporates away from the rock, then this chemical change will be reversed back. In other words, the limonite will be reversed and will come back to limonite after evaporation of water from the rocks. So that is a hydration weathering process. Another form of chemical weathering is what we call the spheroidal weathering. Spheroidal weathering is almost similar to hydration in the sense that it occurs in rocks which can absorb water. Now, when rocks absorb water, the rock surfaces will swell or expand because of the intake of water. Then, when this same rock also loses water through evaporation, it shrinks or it contracts. Okay? Now, in this case, you will find this occasional expansion of the rock surface after intake of water and contraction of the rock surface after loss of water through evaporation will weaken the outer layer of the rock. Then the rock will begin to peel off in thin layers, just like in the same way as exfoliation or weathering is. in the physical weathering process. Except that this is a chemical weathering process because the rocks are attacked by water and the mineral composition in the rocks are chemically changed. The rocks are weakened due to chemical changes taking place within the rock, and eventually the rock begins to crumple down in thin layers. The outermost layer of the rock will begin to peel off because of the effect of the absorption of water. Then we have number 5, hydrolysis weathering process. This is a form of weathering which involves reaction between hydrogen ion with the ions of some rock minerals. The hydrogen ion is present in water. So in other words, hydrolysis weathering process is prominent in the presence of water. Now, how does this hydrolysis occur? When the hydrogen ion in water comes into contact with the rock minerals, there will obviously be change in the chemical composition of the minerals of the rock. And this change in chemical composition will gradually weaken up the rock, and eventually the rock becomes a different form of rock, different form of rock in terms of chemical composition and also physical properties. So such rocks have been weakened up and they can easily crumble through other forms of weathering processes, even physical weathering processes. Now, the best example of hydrolysis can occur in rocks which are made up of feldspar. Feldspar is a type of igneous rock. Is a type of mineral which is very common in igneous rocks. And the feldspars are made up of potassium, aluminium silicate oxide. This is the mineral composition or the compound that makes up the feldspar. Now, when the feldspar is attacked by hydrogen ion in water, then it will be converted into potassium hydroxide and aluminosilicic acid. Aluminosilicic acid is composed of hydrogen aluminium silicate. Then this aluminosilicic acid will further be attacked by chemical means, and the minerals of this aluminosilicic acid will further be broken down into constituent minerals, which will produce clay minerals. So what are these clay minerals which occur in the process of hydrolysis? The clay minerals which comes out of the aluminosilicic acid includes aluminium silicate oxide hydroxide, as you can see in the chemical reaction in the equation here. So you follow this equation, you can be able to understand how the hydrolysis weathering process occurs. Then lastly, we have oxidation chemical weathering process. Oxidation is a form of chemical weathering which occurs basically in metals. Rocks which are made up of metals. And the prominent types of metals which are attacked by oxidation are iron and aluminium. Now, how does oxidation occur? Oxidation weathering process occur when this oxygen plenty in the atmosphere comes into contact with the rocks which are made up of iron. So in this case, you'll find the oxygen, the reaction between oxygen and iron present in the rock will produce iron oxide. So initially, the rock was made up of iron. Then after reaction with the oxygen, it becomes iron oxide. So you can see that from iron, we have already a different form or a different chemical compound within the rock. And that chemical compound is the iron oxide. So in this case, when oxidation occurs in iron, it will convert the iron into iron oxide, which is a weaker form of the iron. So when a rock has been oxidized in this way, the rock becomes weakened up and it can easily crumble. May I illustrate this process of oxidation with the process of rusting? For those who studied the topic of rusting in chemistry in senior 1, you will realize that when oxygen is added to iron, especially in the presence of water, then you will find rusting takes place. And you can know that the rusting has taken place when you see brownish appearance occurs within the iron or on the iron surface. So in the same way, the rocks which have been affected by oxidation process appears brownish in color. You will see some brown stuff appearing within the rock or on the rock surface. So you know that this rock has been attacked by oxidation weathering process. Now when the rock is made up of aluminium, the aluminium within the rock will be oxidized and it will turn into aluminium oxide. So in general, when rocks have been attacked by oxidation weathering process, they produce new chemical compound such as iron oxide or aluminium oxide. And these oxides are the weaker form of the rocks, which can easily cause the rock to be crumpled by other forms of physical weathering processes. For example, by hitting the rock with a hammer, by blasting the rock with explosives, and so many others. So, in this sense, we have come to the end of our lesson. In summary, chemical weathering process involves chemical reaction, and the weathered rock minerals will have their chemical compounds changed to a different form. So in this case, we'll find the rocks which have undergone chemical weathering are weaker, and eventually they can easily crumble down by other forms of weathering process. My dear students, we have come to the end of this lesson. I wish you all the best of this lesson. Please continue to work and continue to read hard, especially during this pandemic as we wait for the schools to be reopened. Thank you very much once again. Take good care of yourselves.